Good evening, guys. In this session, we are going to see tabular method or Cohen-Mikulski tabular method, where we are going to use a tabular technique in finding or in minimizing the given expression by tabular technique. Like how we are going to. There are few steps which you need to follow in making those tables. Now, in the first step, arrange the given minterms in ascending order. Means I need to uh, arrange the given minterms in ascending order, means 0 1 2 3, like those kind of numbers I need to group, and grouping them using n variables. Step 2, comparing the successive groups with one bit difference I need to check for step 2. Next, step 3, repeating the step 2 with newly formed groupings, or we call that newly groups as prime implicants. Fourth steps, the prime implicant table consists of set of rows and columns where terms can be placed in column wise, placing one in the cells. Next, step number 5 gives us the essential prime implicants. When we are grouping them, it is going to give final thing as essential. Step 6, we are going to reduce the given table using prime implicant table. Now, let's see with an example so that we will understand all these steps with an example only. Uh, Now, see here. Now, he has given an example where you can see wxyz, means it's a four variable expression. Wxyz as one example, summation m of 2 6 8 9 10 11 4 11 14 and 15 using 12 Mikulski technique. Now I'm having all the minterms. Now I'm having minterms which are having single ones, two ones, three ones, and four ones. So I'm grouping according to it. So group one, which contains the decimal binary representation for minterms. So 2 can be represented as 0010. 8 can be represented as 1000. Means two numbers contains only single ones here. Similarly, group 2, I'm having group 2 which is having two ones, 6, 9, 10. So these are having two ones in the given number. Similarly, group 3 which is having three ones, that is 11 and 14, that is 10, 11, 14 as triple 10. 15, that is group 4, I am representing it with four ones. So this is how you need to group the numbers in a ascending order, that is single ones in one group, two ones in as the other group, three ones in the third group, four ones in the other group. So this is how you need to represent the first step of given minterms. Then when groups are formed, let's get on to the table 2, how to represent the next thing. So here, once groups are formed, I need to regroup them. Now when one single ones, two ones, three ones, four ones are grouped, now I'm making second table with group 1, which is I'm making a group 1 where I'm comparing 2 with 6, 2 with 10. It means I need to compare the first two with all the remaining things where the difference of two numbers should be one bit difference, one bit difference. Now when I compare 2 and 6, there is only one bit difference at second position, at second position. Now when I compare 2 and 10, the first bit position is having only single bit remaining, remaining will be the same number. Now comparing 8 and 9, there is one single bit difference. 8 and 10 also single bit difference. That difference is represented always with a dash. So when I am comparing the single ones with the two ones, there should be one bit difference, and remaining three bits should be remaining at constant position. Means three bits should be at same level. One bit difference is represented with a dash. Similarly, group 2, 6 and 14 is giving me first bit difference. 9, 11 is giving me third bit. 10, 11, fourth bit. 10, 14, the second bit. Next, group 3. 11 and 15 mean first bit, 14 and 15 fourth bit. So all one bit difference elements are have grouped in my second table. Now when I done this thing, next table should be again I need to combine the G1 group and the G2 group should be compared for single bit difference. Now that is what we are going to do. Now you see here, the previous thing, there were four groups were minimized to three groups. Now again three groups are converted to two groups here. Now if I now the comparison is going between 2 6 10 14, means previously only one dash, now you are going to see two dashes. Now when I compare 2 6 10 14 2, this dash is always there, but one extra dash has came. Why? Because one bit difference should be there again here also. So 1 and 0, 1 and 0. 10, 2, 10, 16, 14. This is what the difference. Next, 8, 9, 10, 11. When compared, third and fourth bit. 8, 10, 9, 11. Third and fourth bit are dashed. One means I need to have only one bit difference. Next, G2. When 10, 11, 14, 15. These are the two positions which are having difference of bits. 10, 14 and 11, 15. 2 bits of information. So this is what you check in this particular table. Now when this is done, now the final step comes. The final step is represented like this, where this is done. Now I compare only G1 and G2. Now when I G1 and G2 is there, now these are all having the same minterms here. Now I am grouping all the same minterms into one group. That is a 2, 6, 10, 14. Now this is 2, 6, 10, 14, 2, 6, 10, 14. I am marking it as 1. Means this both are representing the same thing. These are also representing the same thing. So I am minimizing them. I am just minimizing them. I just represent as two groups now. Now when I minimized it, why? Because minterms are same and the literals are wxyz is also representing same. I am represented them into smaller way. Now after that, I need to write a prime implicant table. Now how to write prime implicant table? So based upon my 2, 6, 10, 14, 8, 9, 10, 11 and 10, 11, 14, 15, I am going to write. So 2, 6, 10, 11 is a group which is representing yz dash, where I am marking given minterms, that is 2, 6, 10, 14. Now again 8, 9, 10, 11 is the box which is representing wx bar, that is 8, 9, 10, 11. Next 10, 11, 14, 15 is a box representing wy, that is 10, 11, 14 and 15. Now when prime implicants table is formed, now this whatever the terms which are given, these terms are called as prime implicants. This prime implicants and prime implicants means if a cell is covered with one minterm, I call it as an implicant. What do you mean by prime implicant? Prime implicant means if I'm able to group two cells, or if I'm able to group four cells, if I'm able to group eight cells, that particular group I am going to call it as a prime implicant. There is one more word called as essential prime implicant. Essential prime implicant means a group should be formed which should not be a part of any other group. Means it should be a group, but it should not be a part of any other group. It should not take a support of any other group. So such kind of groups I call it as essential prime implicants. So implicants, prime implicants and essential prime implicants, these are the three terminologies which you will be seeing under K-map. The same K-map concept, but we are using a tabular technique where we are representing this prime implicants technique. Now from this particular prime implicants table, we need to check only single ones which are there in my table. Now if you observe row wise, means I need to observe row wise directly which are the columns are having only single ones. Now if I am observing the two columns, this is only a single one present here. This is the column which is having single ones here, and this is one which is having single ones. Any other column having single ones? Now this is one which is having single column. Now if you the clear one, now if you clearly observe here, the minterm 2 and 6 are covered only by one prime implicant. Means 2 and 6 are covered by only one prime implicant, that is y dash z dash. Only one thing which is there. Next 8 and 9 are covered by w x bar. Done. Next, the other single ones are present at wy. Only one is present here. So the same representation we are done here in this particular table. So when these are marked together, I am representing those prime implicants with wx bar and wy, and wy as 1. So my final thing is f of wxyz is minimized expression with all these three terms: yz bar, wx bar and wy. See yz bar, wx bar, y. So this is my final minimized expression. So this is how you use uh, tabular method in getting a simplified expression using essential prime implicants. Okay. Thank you everyone. With this we are closing our unit 1, and kindly solve the MCQs based upon this particular topic.